try the counter thing on your own?
Yes, yes, I did, but I tried it on the playground.
Yeah,
Yes, it was a bit tough because it's using a TypeScript.
yeah.
Yes, my mind was wrapped up with the Rust, and when I came back to the counter, I see that it was a bit confusing, even though I went through, but the difficulty is still there. I hope with time I'll become familiar with
Oh,
everything.
okay. So, but you're able to finish it, like the TypeScript, or you left that part?
I couldn't finish it.
Okay, okay. Um, Neutral. How was it for you? Hello, hello, Neutral. You're mute in case you're trying to speak. Okay, I think we just proceed. So let me today's class. I'll make it very simple and fast. I'll just show you. It's this particular class is derived from this. What's it called? Tiny Adventure Project. So I'll just more like repeating myself concerning what we did earlier to make things more clear to you. And I was able to run this stuff locally on my machine. So basically, what I'll be showing you is how to run it locally on your machine. So maybe from next class, we'll do the one that has to do with maybe a DevNet and the what's it called? DevNet and with maybe a simple React app. So what I tried to do earlier was to do implement a simple game, which was um, a game that moves this zero by two dots. So you move left, you move right. Yeah, so it's very simple. So what's required to do this is first of all the person that has to call the instruction as mandated. Yeah. For every movement, it has to be you have to submit a transaction. So you need someone who is able to submit that transaction. And secondly, you need a place to store that data. So that is the state of the position of this circle on the blockchain. So if you remember last time, I said data are stored in PDAs, that is program derived accounts. So I'll show you. So this is how PDAs are created. So PDA you requires a seed a seed phrase like a combination of different seed phrase. So for this one, the seed phrase we used was level, level one, yeah. And before we used level one, we put this B here is to convert it to binary. So this is a string, but by putting B here, you're saying, okay, we want a binary in this array. So everything, so before you use anything for your seed, you need it to represent it as a binary. So when creating the PDA, you also need to attach the signer. That's the person that will pay for the rent of that PDA account. If you remember clearly, last time I mentioned it. So where this data will be sent, will be stored. Person that will be paying for that space, um, that's the signer. So payer is equals to signer. So this signer is this. So the two things required to start this particular program is where you store this data, which is this. So the data type is actually this game data account. So this is game data account. It has just one thing stored in it, which is player position. So what we are trying to do is to pass a bunch of accounts the game data, that's where the data of this game you're trying to play is stored, the signer who is going to be signing it, which is compulsory. Last time we called it authority. So irrespective of, once you just see a signer here, just know, okay, this person is going to be signing this transaction. We might have more than one signer, but um, I've not seen I've not seen a reason at the moment. But just put it in mind that we could have more than one. Then lastly is system program. System program is always needed when in some situations, yeah. Anytime you have a situation where you have to do init if needed, system program is always needed. So this is what Anchor does for us. The moment we try to call the function that does the initialize, which is this, Anchor helps us to create this PDA. So after specifying what we want, how we want our PDA to be structured, Anchor takes it and do the process of creating it. So that's why down here, during the initialization process, we don't have to create the PDA. So what's it called? Um, Anchor does the creation process for us. So when we call the initialize function, what we do is to set the position to 0. That's where we want to start from. And then if you choose any number you want for your own city, but we're going with 0, it's best we go with 0. And then we just send this message out, journey has begun, and then we put the position here. So to move to left, if the person is already at 0, what we tell the person is you are you're at the beginning, like you're basically starting. That's what this is all about, yeah. And then if the if the person is not at the first spot, we'll move the person back, yeah. So same thing with moving forward. We have only about 3 steps, yeah. So from 0 to 3, that's about 4 steps. So if the person has already reached the end, that's the third spot, we tell the person you have reached the end, and then the person can choose to go back again. Yeah. So that's what this is all about. So one thing you will notice is one thing that is this is very simple, yeah, where we just set the data to 0. But when you come down here, you can see the if else statement. You see where we are getting this value and then mutating it down here. So with Rust, when you're borrowing a value and then you hope to edit it else sometime later on, it's important to use this mutation, this ampersand and mutation. So you're trying to say, oh, this value I'm borrowing here, will mutate it. If you don't put this, it will flag you and tell you to put it. So don't worry about the whole complexity too much. So when you see when to put this, when you're signified, oh, that, let me just remove it and try to build it so you see. So when I do anchor build, just going to take a little time. So this is the error. So it's saying cannot borrow immutable. You get, so since here where this error is coming from is from this 21 where we are editing it. So it's telling us, oh, you're trying to edit someone that is not, you're trying to edit a value that is not properly borrowed. So and luckily for us, there's usually suggestion on how to fix it. Let me see. So look at it. It's saying consider borrowing here. So If you use this, you're borrowing it. So even if you borrow it, yeah, it will still tell you that this is not the right borrow function we want. We want a borrow that allows mutation. So let me try building so you see. So this is it. So it says say this is a reference. So data is referenced to cannot be borrowed as mutable. So once you're saying this that this is not a mutable value, that's when you move from doing this to doing this. So it's I won't say it's that easy, but over time you get used to it. So you can see where it even put the whole full suggestion that you should use this. So anytime you see error while trying to write Rust, don't be too scared. Just try and read the error, and then most times you see suggestions on how to fix it. Sometimes you just need to take a part of the error and then Google it. Hopefully, find a solution. So let me try building again. This time it should work properly. Okay, so that's it. So what next? Ne- um, After we is there any question here before I move forward? Anyone with any question regarding what I just showed you guys? Any confusion or anything? So I'll move forward to explain how to connect to this program and then work with it. So um, the important things here when it comes to interacting with a program, you need to establish a connection with the Solana blockchain. You need a wallet to sign transaction, and with that, and then you need to access the program details about the program, which is usually referred to as IDL. Forgotten the full meaning of IDL. So let me explain. Yeah, IDL is like a template of how your program is structured. I should have showed you guys this earlier, but I don't know why I skipped my mind. So let's go through this. So from this one, you could tell the IDL holds every data about the program. Yeah, so this tiny adventure, when you open account, you see this account now holds all the PDAs inside our program. So when you see accounts, you'll see a list. So the name of this account is game data account. What type is it? It's a struct name. So fields, it's just one field you have, which is player position, and it's of type U8. If you check here, it's exactly what we have down here. Game data account, player position, type U8. So that's what this IDL does. It just takes up all the information about our smart contract or program, and then converting it into a JSON that can be read to explain what our program is. This is the function, or call it instruction, initialize. You need to pass in 3 accounts to make it work, but this is not really compulsory. System programs are not necessarily compulsory. I never pass them. So the name of this one is name game account Is immutable? True. Signer. So same thing, move left takes in just one account. That is the same thing here. That is the account that stores our data with move right. So this is a very, very simple program. So um apart from this ideal we have here, note ideal is under target. Yeah. When you go to target, you see ideal. So apart from ideal, what we have next is type. So types has the same thing with the IDL. But the type is to make, if you use TypeScript a lot, you need type safety to work properly. And that's what the type does. It's just a structure of what, it's just a structure of what our program is. So it looks almost exactly like the IDL. So this is the IDL. Looks almost exactly like the types you get. So the types holds a couple of things. The IDL itself and the tiny adventure thing. So what we'll be using majorly is the IDL. So it's just a typed version of what we have here. This is just a JSON data, and this is more like a type. I don't know how else to explain this, but over time we'll get the feel of what it is. So closing targets, we'll go to what's required to establish a connection. So to establish connection, we need to load our wallet. So I believe we've all installed on Solana, yeah, and set it up. So to load our wallet, I usually like, instead of writing the wallet secret key here, I prefer to read it from the local machine. So by the time you if you so this part, yeah, you can find it easily with this Solana command. That is where your private key is stored, your wallet private key. Just do Solana config you get all the information concerning your Solana environment, from which RPC is pointing to, that's the server is pointing to, the socket, and the keeper. So this is what I passed in here, and that's what we use. That's where you're fetching our wallet. So once you see anywhere you see keeper, it's just a pair of your public key and your private key. Um, so now we can move ahead. Um, so next is what we need, connection. We need connection. So we need to establish connection to either devnet, mainnet, or our local testnet. So for this example, I'm using local testnet. So this is the local testnet. And if I want to use devnet, I just do this. Mainnet is this. So, but for the meantime, we just want to use our devnets. Devnets are sometimes easy to work with because you don't have to worry about airdrops and the rest. In fact, on devnet, on your local testnets, you can request for as many airdrops as you wish. Right now, I have um, I have a significant amount of airdrop that should get me a Tesla if it was actual money. So this is it. Type the wrong thing. That's a whole lot of numbers. So on testnet, you can gift yourself as much as you want. So that's testnet for you. So We are connected to our local test nets, yeah, and we establish connection by passing the URL to Web3 connection, and then we load our key pair. This function is from the previous file we went to. This is from this, so we load it in here, and then next is our wallet. Our wallet is created from the key pair. Over time, you understand. Then you can always use your wallet anywhere, but in this situation where we want to create a provider houses both the connection, the wallet, and any other configuration as how to communicate with our the Solana blockchain. So that's what the provider does. It's more like a house for all these things you get. So so when you so to create a provider is from anchor provider, and then you pass in the connection, the wallet, and these were configurations, the personalized configurations go into. So when you do this, we export it into the main function um, that calls our program. So this metadata is missing. I think I just have to deploy and it will come back. But before I deploy, let me see to see if it's truly missing. So under idea, um, so metadata is missing here. I think it's I don't know if it's anytime you build, it deletes or whatever, but to make sure it's there, metadata, you do this anchor deploy. So we're deploying on our local testnet. So deploy successful. Now we have our metadata. Our metadata holds the address to our program. Do I have any question? Okay. So so address holds um, the public key or the address to our program. So next is under the main. Um, what we did here with this metadata is to get the program ID, which was the metadata address. Yeah. And the next is to create the program that we'll be interacting with. So to do that, we do the new program. Yeah. We pass in IDL. The IDL is the IDL I pointed earlier. I said it's important under types.
Can you enlarge the editor a bit?
You said
If you could enlarge the editor so that we can see.
okay to enlarge the ID the code. Hello,
Yes.
I didn't get your question. I'm sorry. So under types, you find the IDL. So this is the IDL we'll be using. So we got the IDL by going to target types, tiny adventure IDL. So once we get the IDL, we next is to pass in the program ID, which is this, and then the provider, which was what we set in the previous class from here under the utils index. This is the provider. So next would be to get the PDA that stores our our data on the blockchain because you want to interact with that account. So to do that, we said find program address, basically program derived address. So what we need to do is to pass just one thing into the array, just our seed, which is level one. If you remember, that's what we used. Where's this? That's what we used here, level one. So, like I said, with respect to this B here, we are passing it as a buffer. So, buffer from, you see this UTF-8. So, it's the buffer standard we're using. The main value is this string. So, this is the encoding standard, the UTF-8. So, once we do this, once we pass the seed, the next thing is the program ID. This, if you pass this stuff, yeah, with a different program ID, that is for a different program, you're going to get it. What you're going to get here is going to be a different global. You're going to get a different address for the PDA. So these two things, they have to be exactly the same for you to get the same solution. You get, so both so these things has to match the same value we have in what's it called? It has to match the same thing we have here in our program. So next would be let's see how to call these programs from the initiate to move left to move right. So everything is basically transactions, as I said, yeah. So we're creating. So what we do first is this is an asynchronous program function. That's why we have the wait function in front of it. So we say program. We call the method. So when we do methods, um, so thank God for autocomplete. So if you're confused, this is basically what you do. You write program. That's this program we created using our IDL and our program ID. So this program is already pointing to our tiny adventure program. So you don't have to do anything difficult again. So next you see methods, accounts, program ID, IDL. So we want to call a method. We click this. Now this method will give us a couple of method options we have from our program. By the time you click the dots, so you see initialize, move left, move right. What we want to do is initialize. So the next thing is you want to pass in the account that is necessary to build to create the instruction. So you see accounts. So accounts takes an object type. So that's where you use the curly braces. So you could from this, if you're not sure which values you need to put in here, you can always make reference to this. So from the initialize, you see that the account you need to pass in is new game data account, signer, system program. Like I said, I don't you don't need to pass the system program. I never do it. So so say new game. Once you start, it completes for you, which is global this, and then the signer. The signer is our wallet. Our wallet dot public key. What you need to pass is the public key, and then the last thing is the signer who is going to sign this transaction, or who is going to be signing this transaction. So it's usually an array, and then we need only one signer, which is the wallet dot payer, which is a valid type of key pair. So we put the payer. So this is what is required. Yeah, this whole thing to call this to initiate this, to start this initiate what's it called, initialize function. So to now call it to our Solana chain, what you just need to do is to call this function RPC, With this function, it makes an RPC call to the Solana blockchain. Yeah, and then you wait for it. So this is basically the same thing I did up here. So what I just wanted to point out is to call a function or to call an instruction, you get hold of the program first. Next is to call methods to see the methods you have. Once you call the method, the next thing is the accounts. You pass in the accounts necessary. And lastly, you sign your transaction. After signing your transaction, you're free to make an RPC call to the server. When you make that call, it's an asynchronous task. It returns the transaction string, which is this. So the same thing applies to moving. Sorry, same thing applies to move right. When you move right, you only pass one account, which is the storage that holds the data. You pass it. Um, Move left, you pass in the account that holds the data. When working with Solana, you always pass accounts around. It's very important. It's very important. You don't necessarily have to cram these accounts. You just need to know how they play in. In this situation, it's just the account is basically level one, which could be named anything. But if you use something that is not in conformance with the program, you run into an error. So when you do this, next, so now we have done this. Let me call these functions one after the other so we see how it works. Yeah. So I've done this earlier, so I'm just going to do it again. Yeah. And then this is to call the initiate function, which is this one, which I explained earlier, just to initiate our transaction, our program. So to call this function, we do npm run main. Just give it let's take a while. And you see and you can see that this transaction hash represents the transaction on the blockchain. It was successful. So next we want to move it to the right. Yeah. And very simple. What you do is this. This alone moves it to the right. And then if you want to read the data from our PDA that stores this data, this is how we do it. We do program account. That means we want to see a particular account on our program, and the account we want to see is the game data account. Then we'll fetch it by passing the ID or the address of that game data. So this is something you get used to over time. Yeah, but it's important to understand this concept. So if you want to read the data from um, from Solana program, you pass in the ID of that program, of that account or that address, which was derived from level one. You pass it into program account. You want to read an account. Unlike before, we are calling methods. This time around, this account you want to read. Remember, this account is different from. I like to point this out. Accounts. This one you're trying to pass in the different accounts that is required to read. This program account, program method is different. Program account, then get data account, then you fetch it. So when we move to right, we'll fetch the data and then we will log it so we can see. So let me run this program again. I've hidden the initiate function. I've commented out so we can move right and see how it works. So by the time we move right, npm run. Yeah, I know it's not very easy to understand. That's why I say if there's any confusion, you could always hit me up. Let me explain again. So we just moved right. This is it. We just moved right just now. So if we want to move back, move left, we call the function move left, which is this method move left. By the time we call this function, can we call this look at it, it moves left back to the earlier function we the earlier position we had. So let's move it to the end of the program. Let us see. So let's move it. Let's just move it two times. Let's see where that gets us to. So move right twice. Yeah. So this is the first. It has moved the first time. So it's remaining the second transaction. So that's this one has completed. So this one that we're trying to execute now. So I've moved it to the second one. And let's do it for the last time. I want us to touch the end. So by the time we run it again, yeah, it should take us to the end of the program. So this is it. We've gotten to the end of the program. So that's basically about it. What's required to this was required to call a Solana program. We've created it. We deployed it to our local Solana testnet, and now we've interacted with it to see that it's working. Yeah, just to read our data, the full data, we could just do this to read the entire thing. Let's just do this so you see what's the data that comes from. So you can see it, the game data itself, position 3, which is the last position. So what we just did here was just to map it to the different, basically to provide a user interface for it. Yeah. So I would like to get any feedback, any question. That's basically about it for today's class. Any confusion, any question?
Yes, Uncle Dochi. I just want to ask, I left some few minutes ago and then I came back. I want
Yeah.
to find the logic behind moving left and right.
You want to find what?
I said I want to find out the logic behind
Moving left and
moving
right.
left and right.
Okay. Okay. So what we are doing to move left and right is just adding one and subtracting one. So depending on where so depending if it's zero, it's here. If it's one, it's here. If it's two, it's here. If it's three. So instead of printing this move left, move right, I'll just show the number. So this is just basically a UI that makes it look much more like a game. So else this is basically a counter. So to move left, this is showing our last result shows three. So let's move left. So by if we move left, it should go to two, right? So um so let's execute. It takes a while. So move left. You can see it now, player position 2. So let me. I don't know if you saw how the code is implemented in Rust. Did you see it?
No, unfortunately, no, I didn't see it.
You said?
But I didn't see it.
Okay, so see, you can see where the subtraction is done. You can see where the addition is done. So if you move right, you add one. You move left, you add one. When it gets to zero, you print out a message instead of moving it to -1. When it gets to three, you print a message instead of moving it to four. So it's just a simple representation of what we can do. So the important thing here is the borrowing function, like here I explained earlier, and that's about it. And before I forget, the okay here you're saying is not a mistake. It's usually required to end your function with okay, that to show that the function was rightly executed. Um, this is the same as saying this with a semicolon, just like every function. So this would work, but Rust says you can make it simpler since it's the last line on your function and you want to return it. Remove the return and then remove the semicolon. Cross no, we just automatically know that oh, you want to return this particular stuff, and which is okay. Your instruction was rightly executed. That's about it. So, any question? Any more question? If there's no question, I'll just go over the important things we learned today. We learned what the IDL does. It stores the data we need to interact with. Um, we also talked about interacting with the with our local blockchain using TypeScript, and that's basically it. And then we talked about the PDA, which we used here. So I think I'll just upload this to GitHub and share the link so that anybody who wants to go over this can see it and then try to practice it themselves, or just run the one I have up. So I don't think I'm missing anything here. Maybe from next class, that's when we interact with React and then do something maybe a little bit more interesting. Is that okay?
Yes, that's fine.
Um, guess that's okay. So that's all about it today. Thank you for showing up, Abu Netro. Thank you for coming. Um, that's the end of our class for today. Kelsey, guess I have to give the mic back to you. Or Victoria, I don't know who's around.
Um, Udochi,
Yeah,
you, thank you. Yeah, I'm just want to say that it's not really easy to grasp. Bele,
yeah, it's not easy.
I guess it will make sense as you get more involved in it. So thank you very much, Uncle Tochi. Thank you for
Yeah,
today. So I think this is still Friday or next week.
yeah, next week, I believe.
All right, that's
Yeah,
fine. That's fine.
okay. Yeah,
All right.
bye. Take
All
care.
right. Bye. Good night. Yeah.
Good night.
Good night. Thank you very much. Bye.